Welcome to the Wine Math series. My name is Erin Norton, and in this video we'll be going through some calculations for yeast inoculations, and we will be using US standard units. If you'd like to skip the detailed explanation and head straight to an example, you can move ahead to the time points listed in the video description below. So let's get started. So what we'd like to do when we're making wine is we're going to take our juice and we're going to turn it into wine. And in order to do that, we typically need to add several things to get that process started. So we're going to make an inoculum. And into that inoculum, we are going to have some water. And we are going to need to put some yeast. And typically we will also use some yeast nutrient to keep the yeast nice and happy. And those are the three things that make up our inoculum. And so when you are using yeast or yeast nutrient, they come in a package that has a lot of information on that package. And so the types of things that you need to be aware of and pull off of the package include what temperature should you be doing the inoculation at? And typically, what temperature should the water be at? You're also going to be pulling out what steps you should be taking. Some products are very specific as to how you need to add them. And lastly, the inoculation rate. So how much per volume of juice that you may have, how much are you going to be adding? And this is what we're really going to be focusing on in this video, is taking that inoculation rate and calculating how much yeast nutrient, or water we need to use to make up the inoculum. So in order to start these calculations, there's a couple of things that we need to know. And the first we just talked about, which is that inoculation rate. And that is something you're going to get from the package. You also want to know the volume of juice, and that you are going to get from your records or from the tank, the volume that you read off of the side of the tank. We are going to want to know the amount of yeast or nutrient that we need to weigh out, and that is exactly what we're going to be calculating. And when we weigh out that yeast and nutrient, we want to know how much water are we going to put that in before we pitch it into the juice. So that is also what we're going to calculate today. Oop, that doesn't look very nice. So just a note before we get started on units. So in this video, we're going to be using and talking about US standard units. There is another video in this series where we use metric units to do the exact same calculations. But we are going to be using the US standard units, and those will look like pounds. Okay, so this is the short form that I will use for pounds, and gallons will be the volume that we'll be talking about. So pounds will be the mass, gallons will be the volume. Now, something to note here is that sometimes pounds is difficult to weigh out, and you may have a scale that doesn't measure pounds but might measure ounces. So how do we convert in between those? Well, 1 pound equals 16 ounces. Okay, and let me just write that down here. OZ equals ounces, in case you ever run across that. So 1 pound equals 16 ounces, and that may be easier for you to work in ounces. Now, we do have another video in this series where we talk about units and interconversion between units. So check that out if you need to understand how to go back and forth between either metric to US standard units or between pounds and ounces. So firstly, I'd like to do a general calculation where we don't know the volume of juice, but this is a calculation you could file away in your back pocket and bring it out at any time that you want to do an inoculation. So you can just plug in the amount of juice. And so the rate typically, which we would find on the side of the package for yeast inoculations, is going to be 2 pounds per 1,000 gallons. Okay, the volume of juice in this example is, we don't know, so we're just going to call it X. And the mass of the yeast is what we're going to calculate. Now, conceptually, the way I'd like you to think about this is if we have a tank, okay, and we had 1,000 gallons in this tank, we would use 2 pounds of yeast. Okay, that's what the inoculation rate is telling us. And so now the way that you can think about it is if I had another tank that wasn't exactly 1,000 gallons, it was a different volume, and it could be more, it could be less, it doesn't matter. Let's say it's X number of gallons, and this is where we are going to calculate that mass of yeast. Okay, so proportionately, that's what we're going to calculate based on that rate of inoculation we get from the side of the package. So, how I set this up, we're going to calculate the mass. I denote that with M of the yeast. I always put a subscript here because I can come back. We're going to be calculating several masses in this video. I can come back to my notes and understand, oh yeah, that was the yeast weight that I calculated. So the mass of yeast in this case, I'm going to start with a number that has the unit that I'm already looking for. I find that's the easiest way to set up calculations. And so in this case, it's going to be the pounds. So I see this 2 pounds per 1,000 gallons. Okay, and when I'm done with all my units at the end, I should end up with that unit that I start with. And then what we're going to do is we're going to multiply this by X number of gallons. Okay, that's our volume of juice. And so when we go to plug everything in, our units of gallons are going to cross out, just the unit. Don't touch the number at all. Just the unit's going to cross out. And we're going to have, when we do this math out, 0.002 pounds times X. So that's our general equation for the mass of yeast that we're going to add. And so we're going to move on and we're going to do an actual example so you can see how you would plug in that volume that you might have. So in this example, we are going to use the same rate of inoculation, 2 pounds per 1,000 gallons. And in this situation, we're going to assume that we have 250 gallons. Okay? And the mass of yeast is still what we're going to calculate. We're going to set that up exactly the same as before. So the mass of yeast is equal to our 2 pounds per 1,000 gallons. Okay, and we're going to multiply that by the volume of juice, so 250 gallons. Again, I'm just going to double check and make sure my units cancel, and we're going to be left with the right ones. So we're going to be left here with just pounds. So that looks good. We're going to take care of the numbers. We're going to compute those, and we are going to be left with half a pound, 0.5 pounds. Okay, and if you think about this, to go back to our conceptual idea, if we had 1,000 gallons, okay, and in this example, we're taking it down to a quarter of that. So 250 gallons is a quarter of 1,000. Then our weight of yeast should also be a quarter. So 2 pounds, and in the rate gives us half a pound. So half is a quarter of 2 pounds. So that does check out for that rate of inoculation. Okay, so next let's jump into yeast nutrient. Very, very similar calculation. We're just going to change the rate up. So typically the yeast nutrients that we use, at least here at the Institute, the typical rate of inoculation for those is 2.5 pounds per 1,000 gallons. Okay, check that your package of the product you're using and to get that number. And so again, we're going to assume that we've got a volume of juice of 250 gallons and our mass of nutrient, we don't know. We're going to set this up in exactly the same way. So this is a good reminder of why I use these subscripts so that I'm not getting confused when I go back to my notes to see how much I added. So the mass of nutrients, we're going to start with our rate of nutrient here, which is 2.5 pounds per 1,000 gallons. And again, multiply that by our 250 gallons. Our units will go the same, pretty much the same way as before. And when we compute this out, we will get 0.625 pounds. Now, again, I mentioned before about ounces. If your scale doesn't measure in pounds very well, you may want to convert this into ounces so that you can measure that out easily. So that's the mass of the nutrient. So again, nutrient and yeast have very, very similar calculations. They may just differ in the rate that you would use those products. So lastly, we're going to calculate how much water we're going to use. And this one is a little bit different. Typically what we see for the rate of the water is you read this from the nutrient package, and it says that you're going to use 20 times the weight of the nutrient. Okay, and that may seem strange to you because water is a liquid and we typically measure it out by volume and not by weight. And I will show you how to get to that volume amount, but you can weigh out your water. There's nothing wrong with doing that. So, so let's go ahead and calculate the mass of the water first. Because if you can weigh out your water and you feel confident doing that, then that is a perfectly reasonable way of getting the amount of water that you need to for your inoculum. So the mass of water is going to be 20 times the weight of the nutrient. So that is what we calculated on the previous slide, 0.625 pounds. Okay, so in this case, it's going to be 12.5 pounds. And that might, again, like I said, that might be easy enough for you to calculate. If you do want to calculate it in a volume, we're going to need the density. And that is why I have this density constant over here. A couple things I want to point out about this, though. So first of all, this is the 8.33 pounds per gallon is the density constant in US standard units. And this is at 68 degrees Fahrenheit. Okay, so it's at a specific temperature. It does change a little bit as the temperature goes lower or higher. So you can go ahead and look that up. It's not a huge change, but you may want to just give that a quick look on the internet. So the way I'm going to calculate the volume using our mass and our density, we're going to go back to that density equation that we may have learned in high school, let's say. So density equals mass over volume. And you could see that in the units, pounds per gallon. So mass over volume. And I'm going to rearrange this equation a little bit. And I'm going to solve for volume. So volume equals mass divided by density. So that's how I'm going to solve this. We're going to come down here. We're going to find the volume of water. And we're going to start with our mass, which we just calculated, 12.5 pounds. And we're going to divide this by our density, which we have up here, 8.33 pounds per gallon. Okay. And our pounds units are going to cancel, and we are going to be left with our gallon on top at the end. So the volume of water in this particular calculation, when we compute this, is going to be 1.5 gallons. So you can go ahead and you can measure out the mass of the water on a scale, or you can measure it volumetrically, and it's going to be 1.5 gallons. Okay, so lastly, I'd just like to point out a couple of useful conversion factors that you may need to use in these types of calculations. So 1 pound is the same as 16 ounces, and that also equals to 454 grams. So in case you prefer to work in and out of metric units, that could be a useful one. A hectoliter equals 100 liters. This may be important, especially when reading the side of a package. In certain countries and regions, they do like to talk in hectoliters. So that might be a useful one to know. 1 gallon equals 3.78 liters, and that's 1 US standard gallon. So don't get confused with imperial. So that's 1 US standard gallon equals 3.78 liters. And then the density of water down here, which you'll need for those water calculations. We've got our US standard unit of 8.33 pounds per gallon at 68 degrees Fahrenheit. And in metric units, it's 1 kilogram per liter at 20 degrees Celsius. So sometimes the metric system is a little bit easier in certain calculations. So thanks for watching this wine math video. If you have any questions regarding the math or the general wine topic covered, feel free to reach out to us at wine@iastate.edu. Check out the other wine math videos to improve your wine math skills in the cellar. Cheers!